All right, so we'll continue with reviews today and Friday. I did today's Advent of Code, but again, they're way too hard this year. This one actually required, at first I thought it required a little bit of calc. No, it just required you to come up with a quadratic equation to represent the solution, and then find the roots of it, and then once you found the roots of it, then you had a range that you could solve this with. We're not going to do that. All right. As much as I love math, this is more programming. So, and this will be more germane to your, relevant to your review anyway, or to your eventual final. I couldn't find it, but an old Advent of Code basically had you doing the following exercise. Where we've got a bunch of zip codes, and I don't know if it was zip codes or just numbers, but we've got a bunch of zip codes here. Some of them are repeated. For example, 64886 right there. That's repeated multiple times. Some of them are not repeated more than once. So what I want to do is I want to come up with a report that says this zip code appears 1 time. This zip code appears 5 times, or something like that. All right. So as a review, first of all, of file I/O, we can go through this process pretty quick of opening up the file and loading up all the zip codes. Okay. Now, again, what we're going to want to do, if I were doing this in real life, I would go back to Hack 10, cut and paste my code there, or just reuse that function, load up all the file lines, and then process each one of those lines. But since there have been additional questions on file I/O, let's go through it one more time. I'm going to skip the error checking here, but I'm going to immediately open up the file, and I'm going to open it up for reading. So if I'm given this file path here, then I'm going to open it up for the purposes of reading. Right? That's file input. Now, again, my standard practice is that when you do something like that and you need to close it, immediately write that code so that you don't forget. Then come back in and fill in the blanks here. Right? So my first step is, 1, count up the number of lines. Because I'm going to want to use this as, this is a small test case with only 18 samples. I've got one with 1 million samples, and I've got one with 10 million samples. There's no way that you're solving that without a program, right? You're not even solving that in Excel. Excel would crash, I'm sure. We need to count up the number of lines. So how are we going to do that? Well, first of all, we need a counter, num lines. I'll initialize it to 0. We also need a pointer because we're going to use forgets to read each line. And so we're going to want to know when we're at the end of the file. Char line is equal to that. And that will return null if while line is not equal to null. Then we need to read the next line, read the next line, read the next line. Forgets will return null when it gets to the end of the file. The arguments to forgets are going to be the buffer that you want to read it into, the maximum number of bytes that you want to read -1 because it takes care of that null terminating character for you, and the file that you want to read from, F in this case. So I need a buffer, char buffer. Now, normally our examples have been 1,000 bytes long, right? 1,000 characters long. Actually 999. Why? Because you need space for that null terminating character. But these are all 5-digit zip codes, right? I'm going to go ahead and kick that down to 100 just because that's big enough. Right? Technically, 5 plus the end-line character plus the null terminating character 7 is enough. So I could get away with only 7, but why risk it? Just go with 100. Right? So I need to increment my counter here, num lines plus plus. Right? And then I need to read in the next line. When I get to the end of that while loop, I'm at the end of the file and I've counted up the number of lines, in this case 18. I need to return these as integers, so I'm going to set up my memory here. Int star result is equal to a call to int star malloc, right? And how big of an integer array do you want? Size of int. And how many of them do you want? Well, however many num lines are. Now remember that this, implicitly up here, this pass by reference variable, that's a bucket that you fill with the number of elements that you're returning in this array, right? In C, you have no way of knowing how big of an array is without doing the bookkeeping yourself. So I want to tell the calling function that there are num lines in that array. Careful, is that correct on line 26? The thing on the left-hand side is a pointer. The thing on the right-hand side is a regular old variable. So how do I make it so that a pointer is a regular old variable in order to assign a value to it? Dereference, right? Asterisk or star, right? Okay. Also down here, remember to return your result. Now, I have nothing in this array yet. I just set up my memory for it. Okay. So what do I need to do now? Well, what if I close the file? Right? Did I ever actually read in any of those values? No. So I need to reopen it and go over it again, line by line by line by line. Or the pointer is pointing to the end of the file at this point. How do I rewind it all the way back to the beginning? Rewind. Right? Remember the nomenclature there. Why is it called rewind? Well, because it was written in an era where data was stored on these big giant tape decks or tape reels or whatever they're called, right? And so you fast forwarded, you rewound, right? You can also use fasik and go anywhere within the file if you want to, but we're not going to. So now I'm back at the beginning of the file. I'm going to do the exact same operation here, right? Read a line, but instead of counting up the lines, I'm going to actually take what's in that line, that zip code right there, and I'm going to convert it to an integer and put it into my result. Results of I is equal to, how do I convert a string to an integer? A to I of the line. That takes care of the end line character, the null terminating character. Now I'm treating these as actual numbers, as integers. Okay. What happens when we have something that is 05556? We'll come back to that. Right? It's going to treat it as 5,556. Okay, fine. We could still count up integers. There's no problem there. All right, and then I read the next line and copy it, copy it, copy it, copy it. Now, obviously, I need that index, int I. I'll start it where? At 0. Once you have once you have put a result in there, then I++. Okay. Now, I've already got some code down here to load up let's load up the zip code test. There we go. And print each one of them out to make sure that it actually works. GCC demo. Good. A dot out. And if you look at this, then it starts at 33992, 33992, and 37152, 37152. I got them all, right? Or at least I think I got them all. Right? How could I tell for sure? Absolutely sure. Start learning command line tools. For example, what I can do with that output is I can dump it to a file, output.txt. Right? Now, let me refresh this and see this output over here. Right? Obviously, the first line is not going to be the same. But if I go back and forth, do you see any differences there? I see one little difference. What? The 0. But other than that, it's all good. How could I automate that process? Well, I could go onto Piazza and I could get that link that we provided everybody to use this online diff tool that highlights everything. Or we could use it from the command line here. Git diff, output, and zip code test. There we go. There. That's basically what the online tool was doing that we suggested that you use for Hack 13. Right? And all it's saying here is in the second file, or the first file, excuse me, you've got 5556, and in the other file you've got 05556. Okay. If you were really pedantic about it, when you printed it out, you could actually print it out with leading zeros. Every zip code is going to be exactly 5 digits, right? So if I want to print it out with exactly 5 columns, that'll pad it out with a space. I can replace that space with a 0, right? And I can get this instead, right? Oops. GCC. Let's rerun it. First of all, let's rerun it straight up. And you'll see that that leading 0 there, perfect. Now let's dump it to that file again. There we go. Output to the file. And now let's do that git diff, right? Loading data. Oh, okay. That's the only thing. I'm including that first line there. Otherwise, everything else is exactly the same. The only reason it's printing this, it's printing it in black to show you that, well, that's the context. These are the next 3 lines. If there are 3 lines before that, it would print that out so that you could look at what lines it's actually doing. And by the way, these are line numbers and column numbers in which they differ. Right? All you have to do is learn how to read them. Okay. So I have a high confidence here that I'm loading up the data properly. What we need to do now is come up with a report. What I want to do, let me open that up again, zip codes, there we go. Oh, no, that's the million one. Zip codes test, they're small, right? Always deal with small ones and then scale it up. I want to come up with a report that says that this one appears once, this one appears twice, if that's the case, et cetera, et cetera. Right? Ideas. Well, let's come over here. What if we approach this from a naive perspective? All right, 33992. What I'm going to do is I'm going to go through the rest of that file and count up the number of times that I see this. Okay? And then report that. I saw that once. I'm going to go through and report and count up the number of times that I've seen 41588. Oh, I saw another time down here, so I'll report that as 2. What happens, though, as I work down this list and get to this guy down here, I've already reported on him. So if I go through this entire thing and report it again, right, it'll still be correct, but I'll be doing way more work than I need to be doing. I'll be doing way more reporting than I need to be doing. Let's try it as an initial solution. For int I equals 0, I is less than n, I++, right? So int x is my current value, or I'll just say a current zip code, right? Is equal to, what did I call it, zips, savi. And now I'm going to go through the entire list again for int j equals 0, j is less than n, j++, and I'm going to keep a counter, int count is equal to 0. Anytime that I see the current zip code, if zips sub j is equal to the current zip, then I will increment my counter. Okay. All right. Then I'm going to report it at the end. Printf of percent 05d. I'm going to get rid of this now. I'll steal this, actually. Print that zip code, but that's going to be the current zip, and the number of times that you've seen it so far, count. So I need a placeholder for that, percent 5d here. I'm just going to make sure that everything lines up really nice. Right? So GCC, let's run this, and there we go. So 64886 appears 4 times, but guess how many times I report that? 4 times, once for each time that it's there. Before I go on, let's make sure that we're actually correct here. And again, this is where command line tools come in. This is not part of the course. This is not going to be required for the exam. I'm just trying to show you and give you a preview of there's some really powerful things out there. For example, I talked about regular expressions before. You can use them from the command line using grep. That's GNU's regular expression operation. How many times did this actually appear? Right? I want to grep for that pattern in the in my output file. So actually I need oh no, in the input file. What was it called? Zip code tests. There we go. It will highlight all instances of that zip code. Okay. Let's go ahead and pipe that. That is a pipe. A vertical bar is called a pipe. What I'm going to do is I'm going to take the output of that one operation and I'm going to pipe it in as input to another operation. In this case, WC, which stands for word count. But I don't care how many words there are. I care how many lines there are. 1, 2, 3, 4. Right? 4. If I were to do that with this zip codes of 10 million, I'm going to get an immediate answer. Codes 10 million. I'm going to get an immediate answer back that zip code appears 111 times in that sample file with 10 million of them. I am not going to even try to open this up. I'm sure that it would eventually, but it might crash the IDE here because there are 10 million lines in that file. Right? It's not big data, but it's big data for a text editor like this. Right? All right, so there is 4. I have some good assurance that this approach is correct. Right? But when I try to run it, say, on those 10 million, let's try it. GCC. And let's run it. How long will it take to do this? So let's look at the code again. N is 10 million. How many times is this for loop going to execute? 10 million times. That's not that big of a deal. How many times is this for loop going to execute? 10 million times. For each time this outer for loop executes. What do we call them? 10 million, 1, 2, 3, 1, 2, 3, times 10 million, 1, 2, 3, 1, 2, 3. 100 trillion? All right. So should I even bother waiting for this? Probably not. You could benchmark it and come out that it'll be several hours, days, weeks, whatever it is. It's not going to be thousands of years or billions of years, but it is going to be intolerable, right? So straightforward code is not going to work. For the last 2-3 weeks, what have we been covering? Searching and sorting. Let's come back to this small test case here, and you tell me, how would you go about using searching and sorting to make this problem simpler and solve the problem of reporting this one 4 different times? Yeah. Okay. So what would that look like? By the way, there are other command line tools here. Let's sort the zip codes test. Right, there we go. That's what it would look like if we sorted it in memory. Right. How does that solve our problem? Where are all 4 of those instances now? They're all together. This is much easier to do now. Why? Start up here. All right. Look at the next one. Is it a duplicate? Nope. So how many times did that appear? Once. How many times does that appear? Look at the next one. Is it a duplicate? Nope. So once. ... Get down to this one that appears 4 times. I've got a counter in my hand right now. I've seen it once. The next one is equal to that. So move on to the next one, increment your counter. The next one is equal to that. Move on to the next one, increment your counter. The next one is equal to that. Move on to that one, increment your counter. That one's not equal to that. Stop. How many times did I count that zip code? 4. Right. So let's come back over here and get rid of this. Mostly, I do want those print statements and I don't want to rewrite them. So let's go ahead and keep that code for now. This should not be in any final submission though, right? Get rid of your cruft and your dead code after you're done with it, right? So first of all, let's sort it. Right? How are we going to do that? I'm going to go ahead and pull out that selection sort that I did from lab 13 or whatever, right? I'm going to selection sort it. Good idea, bad idea. For this one, where there are only 19 or 20 samples, who cares? Small data. But what about this one with 10 million? Same problem here. You're going to be doing 100 trillion operations there, right? That will not fly. Right? That definitely won't work on your final exam. We are going to give you big data, right? So that is not the solution. The solution is to always use QSort. I want to sort, what was it called, zips. There are n of them. It's an array of integers, so that's how we introduce this. It's size of int. And what comparator do we want to use? Well, we got to write it. Right? Or we can cut and paste it from a previous example. Int CMP, or CMP like this, right? Int A, int B. Is that a comparator? Definitely not. Is that now a comparator? Because it takes pointers. Nope. All right, well, we're not going to be making changes to it, so constant. Is that a, nope. Still need void. That is the only thing that is a comparator, right? Period. Okay? First thing we do is typecast them. Const int star x is equal to const int star of a, right? Oops, a. Const int of y is equal to const int of b. Now that I've got them, I can go ahead and compare them. Right? Should I do this? Return x minus y. There are two problems with that. First of all, we've referred to this as the difference trick, and then we told you, hey, it looks like it works, but it doesn't. Why? Remember, 5, 10, or 4 and 5. If I go 4 minus 5, what do I get? -1. Hey, they're in order. That's what I should return. 5 minus 4 is +1. Oh, they're out of order. I should return +1. 5 minus 5 gives me 0. Right? What happens when you have 2 billion and -2 billion? 2 billion minus -2 billion gives you 4 billion. Can you hold 4 billion into an integer? Nope, overflow. Right? It would give you nonsense. We still saw that as a common mistake with floating point numbers. When you tried to take the difference between two longitudes that were very, very close together, you got 0. Why? Well, because you were returning an integer. Right? There's no getting away from it. You need to have if-else-if statements. If x is less than y, then return something negative. Right? Else, if x is greater than y, then return something positive. Else, return 0. There's still something wrong with this. If I use the W flag, it will be apparent. Oops. No space. Huh. What? A.out.w. I wanted GCC W. There. Wall. There. Oh, well, okay. There are a couple of things wrong. I need my comparator there. Oh, it should, you should be detect. No, nope, okay. It's not detecting it. How about extra? Nope, it's not detecting it. What's wrong here? X and Y. If those were regular integers, I'd be golden. X less than Y. Are those regular integers? Nope, they're pointers. So what am I actually comparing here? I'm comparing memory addresses. Okay? All right, so how do I make those pointer variables into regular variables so that I can actually compare their contents? Dereference them. There. I don't want to. I don't want to load the 10 million test. Let's go back to the test. All right, there we go. And let's get rid of the extra stuff. All right, so a dot out. Let's get rid of that wall flag. There we go. All right, it loaded them up. Great. Probably want to print them out now, though. So let me grab this code and uncomment it, but we don't want this bad code right there. All right. Let's just go ahead and print it. Oh, I don't have a count. Int count is equal to 0. So it actually compiles. Oh, current zip. Okay. I do want current zip then. Int current zip is equal to zips savi. There we go. Whoa. Okay, there. Weird. There, finally. All right. So there are all the zip codes in order, but I haven't counted them up yet. Right. Now what we need to do is we need to figure out that code. Right. So for example, how do I go about seeing this as 1 and then reporting 1? And then when I see a current zip code, I want to count 1, 2, 3, 4. Right? So how do I do that? They're all going to be right there. I don't need to look before. I don't need to look after, except for that chunk of zip codes right there. Help me. Well, I could look for 1, right? If the next one is zips sub I plus 1 is equal to the current zip, then I found another. I could say count plus plus. Right? But I also want to increase my index by 1. So I plus plus. Right? That'll do for 1, 2, 3, 4. Right? Am I going to be able to successfully do something like that? No. So, doing this kind of a whiteboarding exercise can get you on the right track. Obviously, I don't want an if here, but that allowed me to figure out this condition right here. Okay. So if the next one is the current zip code, if the next one is equal to the current zip, or cur zip, right, then increment the counter, right, and advance the index. Right? But not if, what? While. Why did you immediately go to a while loop? Why not we could have done a for loop, right? Do I know how many times I'm going to see that zip code up front? No. That's why the while loop is probably a little bit more intuitive in this case. While, now let's take this one. Right? While the next one, I'm at I right now. While the next one is equal to the current zip, I will increment the counter, count plus plus, and increment my index. Right? There. Then I can report all that stuff. Okay, let's try it. TCC. Okay, we're getting something that looks really nice here. Close, not exact though. 05556. How many times do you think that appears? Once. How many times did that one zip code 64886 appear? 4 times. Do you see a pattern? We're off by 1. Why? It's not counting the first time because I set up this count 0 under the old algorithm that we were looking at. Right? This is the first time I've seen it, so I need to start my counter at 1. Then I increase it if I see another one. Right? Okay. There we go. And let's run that now. Looks really, really good so far. How can we check? Well, we could do a find. 99493 or one of those tools that I just said. Oh, if I do a find, I see 1 of 2. In other words, that does appear twice. If I do 64886, that appears 4 times. Looks good so far. 33992, that appears once. Wow. I'm convinced it works until we find a test case that it'll fail on. Right? Because what if it should actually be failing on this one. Come on. Let me put a whole bunch more of them there. So that should appear 5 times now. I don't have to recompile or anything. Why are you working? Oh, probably, okay. Actually, let's do valgrind. It looks like it works, right? Until it doesn't, and then we don't know why. Unless we go back and run valgrind. Valgrind, do we have a clean bill of health? Before I do that, actually, let's recompile it, and let's clean up after ourselves here. Free the zips here, so that we don't get valgrind reporting a memory leak, and giving us a red herring or anything. G, there we go. A dot out. Okay, now valgrind a dot out. Right. There was one error still. Right. When it goes to code post and it doesn't give me any output because it seg faulted, I'll never see why. Right. Invalid read of size 4 on line 82. What are we doing on line 82? I'll give you a hint here. Let me sort zip codes test, right? And let me cut and paste that and put it over here. Can I just create a new file? I guess not. I always like to have a scratch file anyway. Scratch. .md. There we go. Where I can just, scratch piece of paper that you can write something down on. This is a file over here. All right, so let's take a look at what happens in that last report. I start here and I say, oh, well, while the next one is equal to the current one, increment your counter. So now I'm at whatever counter this is. I'll just start it at 0. Now I'm at 1. Count. I'm going to check to see if the next one is equal to this one right now. Is there a next one? No. So what ends up happening here with this, with what valgrind is highlighting on this line? I'm going past the array, right? And it's not manifesting here, and I'm getting away with it. But if this were on a much larger array, I would probably end up seeing it. Right? I would certainly see it on code post. So how do we avoid that? I don't want to look past the entire array. If I is greater than, or if I plus 1, let's say, is greater than n minus 1, then do not look, right? So let's figure out the math there, right? What if well, no, I'll just leave it, do not look. So while I plus 1 is less than n minus 1. Is that right? Less than equal to? Yeah, because I do want to look at the last one. Actually, let's do it like this and see the bug manifest itself. How many times did that appear? 1, 2, 3, 4, 5. I think we'll end up getting 4 out of this, right? And zips, the next one is equal to the current zip code. GCC. Let's run it. There we go. Oh. So, what happened there? I was off by 1, right? And what do we need there? Less than or equal to. While the next one is not equal to the last one. This is saying that it's prior to the last one. Okay. If you wanted to, you could go ahead and subtract 1 on both sides, and it's even simpler, right? The math is exactly the same. Subtract 1, right? No, the math would not be the same. All right, leave it as it is because I think that this works. There we go. Now we're back to 5. And valgrind, tell me, did I screw anything else up now? Nope, 0 errors. Perfect. All right, let's see if this will work for our other values. Let's go up to that 10 million, right? A dot out. It is done, by the way. It takes a long. It got done almost immediately. I'm sure what was taking a little bit longer was actually printing all that stuff out, right? So That's what I would expect because I randomly generated these uniformly at random. So if I've got 10 million and there are 10,000 possible zip codes, then each one would appear roughly 100 times. How could we be sure again? Well, it's grep 49999 out of zip codes 10 million, piping it through word count, counting the number of lines. 98. Take any other sample there. That other one, 2. Perfect. 115. So this is another way that you can do testing, by using a separate tool that you didn't write that you know how it works and is correct. Right? And by the way, we could have solved this entire problem with just command line tools. Don't ask me to do it off the top of my head, but we could do it with awk. Yeah, I'm pretty sure that we could do it. Right? For example, we could do things like this. Let's go ahead and sort the zip code test, right? Remember that I showed you this, but I don't want duplicates here. I can pipe that through unique. What do you think that's short for? Unique, right? And I don't get duplicates anymore, right? All right, command line tools and such. Once again, this one's way too hard to do. So we don't have enough time to complete it, but we certainly have enough time to get started. This is the final exam from 2 years ago. We'll get started on this today and then finish it up on Friday, and that's the end of the review. All right. So back in 1997, Michigan and Nebraska were undefeated. This is before the current FSB, Final Four football teams. And as you see, there's never any perfect solution, right? Already, what was Florida State? Florida State got shafted in Alabama in favor of Alabama, right? Alabama should not be going, right? But anyway, completely different. They change it next year yet again. And then we'll be arguing about that 13th team that didn't make it in and how they're more deserving than whatever, right? Anyway, Scott Frost back in 1997 was advocating that Nebraska should be the sole national champions. Even though they never played each other. They were both undefeated. They both won their bowl games. There was no games after their bowl games. And Scott Frost said, we should be playing Michigan to prove and beat them to prove that we should be the sole national champions, because there were 2 crowned national champions. If you go, if you look at the stadium on the side, it says 1997 national champions. If you go to Michigan, you'll see the exact same thing, right? We were both champions. How can that be? Well, for this final exam, what we did is, well, forget about that one. That's just FizzBuzz. That was 3 points. What we did is we're doing is giving you data. We gave them data, I should say. What does it look like? Let me show you what the data looks like. I didn't have it open. Oh no. Okay. Let me find it really quick. Assignments, fall 2021. There we go. And I'll open up Adam here. All right. Ignore all that. Remove. All right. Here is teams, and here is games. So what we have here are a bunch of universally unique IDs that I generated and associate with each team. For example, Michigan, that's Eastern Michigan. There we go. Michigan has this identifier right here, right? Where's Nebraska? There we go. They have this identifier right here. They're all guaranteed to be unique. Right? I can increase the size there. Over here in this separate file, what we have is the results of 642 games that year in 1997. The way that this works is we've got the away team's ID, the number of points that they scored in that game, and then the home team's ID and the number of points that they scored in that game. We're going to have to process this to find out how many wins each team had, how many losses each team had, how many points each team scored, how many points were scored against each team, in order to produce a report that looks something like this. Right? Nebraska and Michigan were undefeated. 11-0 and 11-0. This back then they only played 11 games. Right? In fact, did they only play 10 games and then the 11th was their bowl? Does anybody know Nebraska? Of course, right before this is some sort of sports history. I should have asked him before he left. Right. Anyway, they have a win percentage of 1. Right? It's usually expressed as on the scale of 0 to 1. Florida State and K-State looks like they were pretty good that year as well, but they both had 1 loss. So the way that we want to differentiate teams with the same win-loss record is by the point difference. The point difference is going to be the number of points that they scored minus the number of points that were scored against them. So in other words, Nebraska scored 329 more points than were scored against them. Poor Rutgers down there, if they scored at all. Other teams scored 305 points against them more than they actually scored. Okay? So this is the report that we need to come up with. How would we go about doing that? Well, first of all, we gave starter code that year. Let's see. Yeah, here we go. All right. So let's take a look. Always good to look and see what you've been given to see if you can use it. We've been given this function here to split a string. It's a utility function that splits a string into an array of strings along a provided delimiter. In other words, if you're going to be processing CSV data, that would be super helpful, right? Because once you split it, you will get, in this case, 2 tokens. In this case, you'll get 4 tokens. Good. Chomp removes any trailing white space from the end of the string. That seems useful because if you're going to be using forgets, remember that there's this endline character at the end of each line. I want to chomp that out. All right. Free string array. Once you've used split, you'll probably want to free that up so that when you run valgrind to check for any errors, you're not getting any false positives by seeing memory leaks. Okay. Other than that, we gave full implementations for those things. Other than that, you can write whatever functions you want. You just need to, produce this report. Before we start writing any code to actually process any data, let's think about what building blocks we should give to ourselves in order to represent that data. Looking at one line here, what pieces of data do you see? Let's just look at one line right here. Okay, I can't highlight it because it's a preview. There, like that. I see a team name. I see a win total. I see a loss total. What about the percentage? Is that another piece of information? No, because you could just take the wins divided by the wins plus the losses, right? So that's not real data. What about this? I see a point difference, but implicit in that is the points for and the points against. So I see 5 pieces of data for each team. What should that be screaming out to you? 5 pieces of data that I need to treat as one so that I can sort it by win-loss records. A, structure. So let's give that to ourselves as a first step. All right. Type def, struct. I'll just call it team. No need to go NCAA, football, whatever team. Just go team. Keep it simple. All right. What pieces of data do we want? Char star name. Int wins. Int loss. We could say losses and be consistent about it, but I like things that line up. 4 characters. Right. What else do we want? Points for and points against. Right. Points scored, let's say. There we go. Again. Can't do that. We're not going to be able to come up with one that lines up like that. Right. Points scored and then points scored against them. Right. If I have all 4 of those, does it become apparent how I can do this really easily? One comparator. What would your comparator look like? Let's come back over here and cut and paste this so that we can look at it over here. What would your comparator look like to sort everything to produce that report? Int, CMP team, right? Const, void star A, const void star B. All right, there we go. And the first step is to cast them as their proper types. Const team star X is equal to. I haven't even processed the file yet, and I'm thinking ahead to the tools that I need to do this. Right? B. There we go. All right, help me out. The win-loss record should be first, right? So we need to compute the win percentage, right? So X win percentage right, is equal to X's wins divided by X's wins plus X's loss. Okay. Y's win percentage is going to be Y wins, and Y losses. Be careful. What's an error already? Integer division, exactly. So let's take care of that and force one of them to become a double spelled correctly. There. Now, if I can already find that, well, they have a higher win percentage than they do, I can immediately return a result. If X's win percentage is greater than Y's win percentage, well, we want those at the top, right? So they are in order. I return something negative. Else, if X's win percentage is lower than Y's win percentage, then they're out of order. And QSort would need to swap them. So I return something positive. Else. Now be careful. Nebraska, Michigan, they have the same win percentage. So what do I look to now? The point differential. Right? That's called the point differential. Right? And I'm not sure FSB it's more strength of schedule, isn't it? All right. No. Yes. No. No sports fans out there. Okay. Anyway, I'm not enough of a sports fan to go into the analytics of football. I'll go into the analytics of baseball anytime you want, but not in college football. Who cares? Right? All right. So I have a tie with respect to win percentage here. I need to look at the point differential. So X point diff is equal to X's, what did I call it? Points scored minus X's points against. Right? Same thing for Y. Y. And then I can make a determination. If X's point diff is less or greater, right? Greater point differentials come first. Y's point diff, then I'll return something negative. They are in order. Else, if the point differential is out of order, then I will return something positive. Else, return 0. Now, the likelihood that two teams out of 142 had the exact same win percentage and the exact same point differential is very low, but we could break ties there by maybe team name for breaking ties. It really doesn't matter, right? QSort will see, oh, these two things are equal. I'm not going to swap them. I'm going to leave them where they are. Right? There are data structures where you do have to have a total order and say, oh, these two things are the same. All right, I'll throw that one away. Right? And you got to be careful on that. Right? All right, so there's my comparator. That's all the starter code that we gave that year. Let's get rid of this before I forget that it's in there. It's in the header file. Right? That's all the starter code we gave for that year. So how would we go about actually processing these two files? We're not going to have time to do it today, but I will outline it. Open that file. Read it line by line by line. For each line, what do? Remember, we gave you this function, split. Split it up into its tokens. For the teams, you're going to create 145 teams. You can hard code that actually because this was we only gave them one file that year. Once you've got all of these teams initialized, by the way, what are we going to initialize them to? There's the name. That'll be useful. Oh, by the way, what else do we need? char.uuid. I forgot about that. That's how we're identifying a team. even though we never actually printed over here, we need it because if I need to know, what team was that? What team was the away team in that second game right there? I need to come over to this other file and find it. But I'm not going to go to the file. What am I going to do? I'm going to load up this entire file and associate each one of these UUIDs with a team. Then I'm going to sort them by UUID. And then I'm going to search for them by UUID so that I can find Iowa State. When I find Iowa State, I see, they scored 17 points. I'm going to increment the number of points that they scored by 14. What about whoever they played there? They scored 57 points. So where would that come in with respect to Iowa State? Points against 57. Right. Sounds about right for Iowa State back in the 90s, right? All right. So anytime you win, by the way, I know that was that a win or a loss for Iowa State? All right. Where was it? Iowa State's right here with 17. Whoever this is had 56. So what would I do with Iowa State? Loss +1, right? Not a win, right? Whoever this was would receive the win. So who was that? Texas A&M, right? So for each one of these games, I'm going to need to process all those that data. There are 642 here. Note that some of them, I think that there's a note here. The data includes non-Division IA teams, such as Nicholls State. Ooh. So your report should only include teams that played 10 or more games. When we go to print it out, that's when we'll filter it out, right? Because what is I know who Nicholls State is, but how many people know who Nicholls State is? All right, not many, right? I have no idea what division they were in then, certainly not now. But anyway, there's Nicholls State. If you look at the scores over here, they only appear once, right? Because it's one of those non-conference games that you get somebody to come in and play for the first 3 games of your season, right? And they didn't even score a point. So we're not even going to want to pay attention to them. We're only going to want to look at teams who had played 10 or more games. In this case, I think that there are some teams that played full 11 season, some teams that played only 10 that season, but we want to include them, right? So that's where we'll pick it up next time. We'll be able to finish this all on Friday. I'll also give details other than I can give you quick details now. It's on Wednesday next week. You'll have a 24-hour period. It's asynchronous. You don't have to be here. Nobody will be here. If you want to, you can take it anywhere you want. Just take it alone. No help from anybody. You can post to Piazza. We won't be giving as much help as usual, and there are no help hours down in the SRC or in the lab. If your computer dies, right? If you lost your computer, you got stolen or whatever, get to the lab. Those computers are there, available to you 24/7 with your N card access. Right? We'll go over that again on Friday.